Scenario: a volleyball player serves the ball. The player hits the ball and the ball follows a projectile motion path before hitting the net with an elastic collision at T1. After the elastic collision, the volleyball falls straight down. Question: you're going to graph the horizontal velocity and the vertical velocity of the scenario. Here's the horizontal velocity and here's the vertical velocity. The answer: this follows a projectile motion. What I demonstrated to you here is the vector component of the horizontal, which is the blue arrow, and the vertical velocity, which is the orange, as it goes and undergoes a projectile motion. They should help you answer this question. Notice that the horizontal velocity, which is the blue arrow, does not change size. It is constant until it hits the velocity, which is on top here. That is the moment that it hits the net. Once it hits the net, there is no more horizontal velocity. So that flat line here is that constant velocity before it hits the net. Once it hits the net at T1, it no longer has a horizontal velocity because it hits the net and stops. Then it falls straight down. As it falls straight down, there is no horizontal velocity. That is why the second part is flat. This is considered a piecewise step function. It's constant, hits the net at T1, then becomes 0. The vertical velocity is given by the orange line. Notice as time goes on, the horizontal velocity vector decreases in size. That's why you're going to have a linear line with a negative slope. That demonstrates that it's going to go down. Notice that it does not hit 0 because it hits the net. That moment that it hits the net, it falls straight down. As it falls straight down, look at the orange vector velocity. It is increasing in size, pointing down. That's why the second part, it is going down negatively, and it is also linearly as well. This would be the horizontal velocity and the vertical velocity of the volleyball